almost 94 million miles from Earth, a powerful light show on the surface of the sun. The bursts of radiation are the strongest solar flares so far this year.
The biggest solar storm in 20 years just hit Earth, and it's not over yet. It started with a flash, an intense burst from the sun, and within hours, Earth was in its path. The largest solar storm in 2 decades has slammed into our planet, lighting up skies, disrupting satellites, and leaving scientists on edge. But here's the thing, this isn't just a one-time hit. The storm is still unfolding, and experts warn that the worst might not be over. From power grid concerns to potential GPS blackouts, the ripple effects could touch every part of modern life. So, what caused it? How bad could it get? And what does it mean for you? Buckle up, because we're breaking down everything you need to know about the solar event shaking the planet right now. In one of the most intense cosmic events of the last 20 years, Earth was recently slammed by a massive solar storm, and it put on a show for the ages. It all started with a cluster of sunspots so enormous they were roughly 16 times the size of Earth. From deep within that fiery patch on the sun's surface came a series of powerful X-class solar flares and coronal mass ejections. Think of them as solar shockwaves hurled straight toward our planet. What followed was no ordinary space weather. As those charged particles collided with Earth's magnetic field, they triggered a rare and powerful geomagnetic storm, ranked a full G5, the most extreme level on the scale. The last time we saw anything like this was back in 2003, during the infamous Halloween storms. The result? Nature's light show exploded across the skies. The auroras, usually confined to the far north or south, broke all the rules. People in places as far south as Florida and Mexico caught the magical dance of the northern lights. On the other side of the world, the southern lights lit up skies over New Zealand, Australia, Chile, and Argentina. But this storm wasn't just pretty, it packed a punch. The solar surge didn't stop at stunning visuals. It rattled our tech too. Starlink, Elon Musk's satellite internet service, took a hit. Musk himself posted on X, formerly Twitter, saying the satellites were under a lot of pressure though. So far, they're hanging in there. Down on Earth, power grids groaned, GPS signals wobbled, and high-frequency radio communications in some areas went dark. And here's the kicker, this could just be the beginning. The sun is ramping up toward its peak activity in the current solar cycle, meaning more solar drama might be on the horizon. So, if you miss this round of auroras, don't worry. Keep an eye on the skies and maybe double-check your tech. What we've just witnessed might be a sign of something bigger brewing in the heart of our solar system. The sun is entering what's known as the solar maximum, the most active and unpredictable phase of its 11-year cycle, and it might be arriving sooner than expected. As the sun's powerful magnetic field prepares to flip a wild process that happens about once every solar cycle, we can expect a rise in solar fireworks. Translation: more geomagnetic storms, more breathtaking auroras, and, more potential disruptions to our power grids, satellite systems, and global communications. But let's rewind for a second. What exactly happened on the sun's surface to unleash this recent solar storm? How did an event 93 million miles away light up our skies in such a spectacular way? And perhaps the biggest question of all, what's coming next, especially when this same sunspot cluster swings back around to face Earth in just a couple of weeks? Before we dive into the details, don't forget to hit that subscribe button so you never miss a moment of space news that could change the way you see the world or the sky. The main culprit behind all this cosmic drama, a monstrous sunspot group named AR3664. Now, if you're not familiar, sunspots are dark, cooler regions on the sun's surface. They might look like harmless shadows, but don't be fooled, they're the epicenters of some of the sun's most explosive behavior. The center of a sunspot sizzles at 3,000 to 4,500 Kelvin, significantly cooler than the surrounding surface, which burns at around 5,800 Kelvin. But what they lack in heat, they make up for in raw magnetic energy. AR3664 first rotated into view just a few days ago, looking fairly tame, nothing out of the ordinary. But then, like a sleeping giant waking up angry, it exploded in size. In a matter of days, it ballooned to a staggering 125,000 miles across that's 16 times the width of Earth. And when that beast turned to face us, the result was a geomagnetic storm, powerful enough to paint the skies with color from pole to tropic, and to shake up satellites and systems worldwide. Now here's the twist. That same sunspot cluster is currently rotating out of view, but it's not gone for good. In about 2 weeks, AR 3664 will be back. And the big question is, will it still be active? Will it pack another solar punch? Or will it have cooled off? AR 3664 didn't just show up, it made an entrance. This massive sunspot quickly became one of the largest of the entire solar cycle. Early this month, NOAA's Space Weather Prediction Center flagged it as a serious threat for increased solar flare activity, and wow, it delivered. In just 1 week, AR 3664 unleashed a storm of energy, firing off a jaw-dropping 75 M-class solar flares and 10 X-class flares. Those are the strongest types we know of. In fact, this one sunspot was responsible for half of all the X-class flares Earth has seen this entire year. Let that sink in. So, what's a solar flare exactly? Think of it like the sun's version of a sudden explosion, an intense burst of radiation that lights up space in a flash. These flares can last anywhere from a few minutes to hours, and when they go off, they release more energy than millions of nuclear bombs. Even from 93 million miles away, the radiation from these blasts reaches Earth in just 8 minutes and 20 seconds, as fast as light can travel. Flares are ranked by strength, and here's how it breaks down. B-class is the weakest, C-class is mild, M-class is moderate, but can cause disruptions, and X-class. That's the heavyweight category, the kind that can mess with satellites, power grids, and even airline navigation systems. Each step up the scale multiplies the power by 10 times. So, an X-class flare isn't just a little stronger than M, it's a whole different beast. And with AR 3664 still lurking and due to swing back around in the coming weeks, the show might not be over. Keep watching the skies and keep your tech grounded, because the sun isn't finished with us yet. Alright, let's break this down. Not all solar outbursts are created equal, and understanding the difference can change how you see space weather entirely. First off, solar flares. These are ranked not just by letter class, like B, C, M, and X, but also on a scale from 1 to 9 within each class. So for example, an M9 is way more intense than an M1 and a lot closer to entering the powerful X range. C-class flares, those are lightweights. They barely nudge Earth and usually go unnoticed. But M-class flares, now we're talking. These can cause short-lived radio blackouts, especially near the poles, and minor radiation storms, the kind that could affect astronauts or satellites. But here's where most people get tripped up. Solar flares aren't the same thing as coronal mass ejections, or CMEs. So, what is a CME exactly? Imagine the sun hurling a massive, fiery blob of magnetized gas into space at over 1 million miles per hour. That's a CME. These blasts happen when the sun's magnetic fields snap and realign in a violent release of energy, flinging charged solar material far beyond the sun's surface. While solar flares are more like bright flashes of radiation, CMEs are giant waves of solar plasma, a rolling tsunami of space matter. They're bigger, slower, relatively, and they pack a different kind of punch. When a CME finally reaches Earth, which can take anywhere from 15 hours to 3 days, it crashes into our planet's magnetic field, sparking massive electrical currents that drive particles toward the poles. The result? Auroras. those dazzling lights dancing across the skies. Thank a CME. So, to sum it up, solar flares are bursts of radiation. CMEs are waves of solar material. Both come from magnetic chaos on the sun, but they move differently, hit differently, and affect us in completely different ways. And with the sun revving up for its solar maximum, we're likely to see a whole lot more of both. Solar flares and CMEs may both come from our sun, but they're two very different beasts. Flares show up as sudden, blinding flashes of light. CMEs, they're massive ballooning clouds of magnetized particles ripping through space at breakneck speed. This latest round of solar activity kicked off on May 3rd, when an X-1.6 class flare lit up the solar surface, the warning shot. Within just 48 hours, the sun fired off 2 more X-class flares like it was just getting warmed up. But then came the real showstopper. On May 5th, the Sunspot region cranked out a monstrous X-4.5 flare, releasing an enormous surge of energy. The very next day, May 6th, scientists spotted the first coronal mass ejection, CME, tearing away from the sun, racing towards space. Things didn't calm down. In fact, they escalated. By May 8th, after an M8.6 flare, another CME was on the move. And then, on May 9th, 2 more X-class flares exploded, and yep, 2 more CMEs followed. By May 10th, we had 4 CMEs, all on a collision course with Earth. But here's where it gets wild. Scientists believe the last 3 CMEs caught up with each other, their speeds and paths overlapped, and they merged into a single, monstrous solar event. It's called a cannibal CME because the faster ejections literally consume the slower ones ahead, creating a bigger shockwave. So, what happens when a CME finally slams into Earth? Well, our planet's magnetic field acts like a force field it pushes back. But in doing so, the magnetic fields from the Sun and Earth can link up, forming a funnel that channels solar particles toward the poles. That's when you get those brilliant auroras, and also when satellites, GPS, power grids, and radio systems start feeling the pressure. And this storm, it's a clear sign the sun's ramping up, and we could be in for an even bigger blast. So here's the deal. When a solar storm hits Earth, it doesn't just light up the skies, it kicks off a chain reaction that wraps around the entire planet. On the day side, Earth's magnetic field gets slammed, and particles from the sun spiral down those field lines, creating glowing light displays in real time. This is what we call a daylight aurora. But that's only half the story. As the storm energy stretches our magnetic field way out into space, on the night side, it's like pulling back a giant rubber band. Eventually, the tension snaps, and when it does, all that solar gas comes rushing back in, funneling down toward the poles again. That's when the nighttime auroras come alive. Most of us think of auroras as that eerie, electric green, but during stronger storms, they can explode in deep red, and that's a big deal. The color all depends on what kind of particles are colliding with what and where in our atmosphere it's happening. Blue and purple auroras show up when solar particles hit molecular nitrogen at lower altitudes around 62 miles, 100 kilometers, above Earth. Green is the classic, and happens when those particles interact with oxygen at altitudes between 100 to 300 kilometers, 62 to 186 miles. Red, though, that's rare. It means serious solar activity. These glowing crimson skies happen when solar particles hit oxygen way higher up, between 300 to 400 kilometers. And for your eyes to even see that red, it has to be 10 times brighter than the green. Beautiful? Absolutely. But red auroras often mean Earth is taking a beating. And it's not just light shows we have to worry about. When the sun unleashes a strong geomagnetic storm, it can create something called geomagnetically induced currents, or GICs. These invisible power surges flow straight into electrical transmission lines and transformers. That's where things get risky. Those surging currents can overheat transformers, trip protective equipment, overload transmission lines, and even wreck generators. In worst-case scenarios, this can lead to massive blackouts, the kind that knock out cities, disable satellites, and ripple through our modern infrastructure. So the next time you see the sky glowing red, it's not just a pretty sight. It's a warning from 93 million miles away that the sun just reminded us who's boss. If you think solar storms are just science fiction, think again. Back in 1989, a powerful geomagnetic storm knocked out the power grid in Quebec, Canada, plunging 6 million people into darkness for over 9 hours. No warning, no backup, just lights out. Fast forward to October 2003, when the infamous Halloween solar storms caused chaos in space and on Earth. Satellites glitched out, radio communications went dark, and Sweden's power grid took a serious hit. And it's not just old news. Even recently, in 2022, a solar flare from the sun wiped out 40 freshly launched Starlink satellites in one shot. That's right, one solar outburst and tens of millions of dollars were gone. Now, here's the twist. The current troublemaker, a massive sunspot group named AR3664, has just rotated behind the sun's disk out of view from Earth for the next couple of weeks. So, for now, we're in the clear. Any solar flares or CMEs it fires off won't be Earth-directed, at least not yet. But don't get too comfortable. This beast isn't done. It's expected to swing back around in about 2 weeks, and based on how it was behaving before it disappeared, we could be in for another round of fireworks. Right before it vanished from view on May 11th, AR3664 was still going strong, unleashing an X-1.8 class flare, and then a monstrous X-5.8 flare, both high-energy blasts. The second one even came with a CME, the kind that can disrupt satellites, power grids, and GPS if aimed at Earth. So, what does this all mean? AR3664 is likely still active, still cooking, and might be gearing up for another round when it rotates back into our line of sight. And if history tells us anything from Quebec to Sweden to Starlink when the sun aims, we feel it. Let's talk about AR3664, because this sunspot isn't your average cosmic blemish. It's huge. We're talking so massive, you could actually spot it from Earth with the naked eye, no telescope needed. But seriously, don't try that. Never look directly at the sun unless you've got proper eclipse glasses or a certified solar filter. Your eyes aren't built for that kind of heat. Now here's where things get wild. AR3664 is about the same size as the legendary sunspot behind the Carrington event of 1859, the most intense geomagnetic storm in recorded history. That storm lit up the night skies with auroras as far south as Mexico and the Caribbean. Telegraph lines, the cutting-edge tech of the time, sparked, caught fire, and shocked operators, all without even being plugged in. But that was 1859. Back then, the most high-tech thing we had was the telegraph. Today, we live in a world powered by satellites, GPS, internet, electric grids, air traffic systems, financial networks, all of it completely dependent on a stable magnetic environment. And that makes us way more exposed than we were back in the 19th century. If a modern-day Carrington-level event were to hit us now, the impact wouldn't just be inconvenient, it could be catastrophic. Think trillions of dollars in damages, widespread blackouts, communications failures, GPS going offline, and critical systems including hospital and emergency infrastructure grinding to a halt. AR-3664 has already proven it's capable of producing high-powered flares and CMEs. If it fires off another direct hit when it rotates back into view, we could be in for more than just a light show. This isn't just space weather. This is a reminder of how small and connected we really are, and how one sunspot could flip the switch on the modern world. If an event like the Carrington solar storm happened today, experts estimate it could cause between $600 billion and $2.6 trillion in damage in the US alone. We're talking mass power outages, crippled satellites, GPS failures, and internet blackouts. Basically, everything modern life depends on could be at risk, and that's not science fiction. That's science fact. The recent solar storms in May 2024 weren't just beautiful light shows in the sky, they were warning shots, signs that the solar maximum, the most intense part of the sun's 11-year cycle, could be hitting sooner than we thought, as its magnetic field begins to flip. This is the time to pay attention. That's why we've put together a deep dive video explaining everything about the solar cycle, how it affects Earth, and what you can do to stay informed. So, if this video opened your eyes, hit like and tap subscribe so you never miss a cosmic update. Thanks for watching, and we'll catch you in the next one, where we'll dive into what happens if AR-3664 flares up again. You won't want to miss it.